We're continuing to look at marginal analysis, and we will go through these few examples here. For the following total cost functions, so these are the total cost functions, you must find the average cost function, the marginal cost function, also the marginal cost function for x equal 3. Alright. Let's say this is A, this is B, this is C. Let's work out A. The average cost. The average cost would be the total cost divided by the number of items. Alright? So the average cost of this, let us call it CAVG of x, would be 5 plus 5x. X is the number of items or units, so you divide by x. So what this would give you is 5 divided by x plus 5x over x, but x would cancel x here. So it all comes down to 5 over x plus 5. Okay, so that's the average cost function for A. Let us find the marginal cost function for A. Well, in this case, you have the derivative, let's call it C prime of x, derivative. So this would be the derivative of 5, which is 0, plus the derivative of 5x, which is just 5. Alright? That's just 5. Now, question. What is the marginal cost at x equal 3? By the way, this was part 2. Let's look at part 3. At x equal 3. So C prime of 3 would be what? Well, it's just 5. 0 plus 5 is 5. So whatever it is, it's just 5. Alright? Now, in this case, what you're looking at is a case in which the marginal cost is always 5, whatever the value is. Now, we looked at this marginal cost using the derivative. Remember, the marginal cost is the cost, what the cost would be if an additional product was manufactured. So another way we could find this marginal cost is to say what is the cost at x equal 3, also what is the cost for the next one, which is x equal 4, and then subtract them. So let's do that. Let's do that. We're just concentrating on A for now. C, the cost of 3 using the total function. Remember, this one was the derivative. This is not the one we're concentrating on now. Let's use the total cost function and find it by finding the cost at 3 and the cost at 4 and subtract them. It's not supposed to be exactly the same, well, in most cases, but we will see. C of 3 is 5 plus 5 by 3, which is 5 3 is 15 and 5 20. C of 4 is 5 plus 5 by 4. 4 5s, 20 and 5, 25. When you subtract C of 4, and C of 3, what do you get? You get 25 minus 20 equal 5. Now in this case, we see that the marginal cost when you use this total cost function and subtract is equal to the marginal cost using the derivative. Let's examine this thing using a graph. 5 plus 5x. We want to plot the graph of 5 plus 5x. 5 plus 5x. Aha, there we have our line. Let's make our line thicker than it is right now. Okay. And I like to see the equation on the line. Alright, now this is 5 plus 5x. We did the calculation for 3 and also for 4. So let's look at this. 3 and 4. This line is 3 and the next line is 4. Now the values at 3. This is the 3 line and this is the 4 line. What is the gradient of the tangent at 3? Well, the gradient of the line at 3, rise over run, is this. Right? Trying to make straight lines. The gradient of the line at 4 is this. So it's the same gradient. 5. It is the same gradient. So in that case, what you get is 5 in both cases. Alright? But generally, to find the marginal cost, you find the derivative of the function. If you find the cost using the total cost function, find the cost for this one that you're dealing with and the next one and subtract them. This is also the marginal cost, but it is an approximation. Alright? Now, let us look at part B in a different video. So I will see you in the next video.